Hey, hello, Algebra 2. Hope you guys are doing well. This is going to be part 2 of the LFR1 slope and rate of change video. So, without further ado, I'm going to go over to the Promethean board behind me and let's finish this guy up. All right, so what we did before, what we've done up to this point is really the mechanics of slope. M equals y2 minus y1 divided by x2 over, I'm sorry, m equals y2 minus y1 divided by x2 minus x1, right? So that's the mechanics of slope. That's just, the slope, how you calculate it when you're given 2 points, or how you're trying to find slope. We talked about rise over run. But the real reason that we're talking about this today is the interpretation of slope. What does it mean? How do you take a graph that's not just numbers? How do you take something real world and apply it and make it make sense? So let's go ahead and talk about that one. So explain 3, interpreting slope. Given a real world situation, you can find the slope and then interpret the slope in terms of the context of the situation. Context of the situation, what does it mean? That's what we're looking to do. So let's take a look at this one here. Find and interpret the slope for each real world situation. We have a graph, and on the x-axis we have maximum heart rate in beats per minute. Oh man, on the y-axis we have maximum heart rate in beats per minute. On the x-axis here we have estimated maximum heart rate. We've got a couple points in here. We got a couple points. We have 20, 20 comma 180, 50 comma 150, right? Our slope is our rise over run. We could also make this look like y2 minus y1 over x2 minus x1. We have 30 divided by negative 30, which gives us a negative 1. So if I'm looking at this business right here, this line goes downhill. So we know at minimum that it's got to be a negative slope. We did come up with a negative slope, but that's fine. Negative 1. But what does negative 1 mean? This is your 3-level stuff. What does negative 1 mean? Now, if we take a look at this, we know that it's heart rate and year. This is our y. This is our x. Rise over run. We're going to put the y on top of the x. So this is like negative 1 beats per minute per year. But what does that mean? What does that actually mean? In other words, every year, if this is like over 1, right? Negative 1 over 1. Every year, my maximum heart rate decreases by 1 beat per minute. That's one way to think about this. That's one way to interpret this thing right here. We got maximum heart rates in beats per minute per year. We take the units here and the units here and combine that. That's what we got. Let's take a look at this second one here. The height of a plant, y in centimeters after x days, is a linear relationship. The points 30, 15, and 40, 25 are on the line. So this is our days. These are our days, 30 and 40. And our y is our height. So we've got x1, y1, and x2, y2. So let's go ahead and fill in the boxes. I'm not a huge fan of boxes, but we can do this here. We've got y2, which is 25, minus y1, which is 15, divided by x2, which is 40, minus x1, which is 30. We have 25 minus 15 is 10, 40 minus 30 is 10, and we end up with 1. 1 what? So we need to interpret the slope. The slope being 1. I'm going to give you a second to think about it. If I was to graph this, this would be days. This would be centimeters tall. So if I'm thinking about this, this would mean that every day, every 1 day, I increase 1 centimeter. Because that's my slope. It means every day, every 1 day, or every day, the plant grows 1 centimeter. That's our interpretation. Now here's another one. They're both 1, right? Not great examples when you have them both be the same thing. So let's take a look at this one. Let's take a look at this one. This is kind of an interesting one. We've got, the graph shows the relationship between the temperature expressed in Fahrenheit and the temperature expressed in Celsius. Celsius is on our y, Fahrenheit is on our x. We have 2 points. I'm going to treat this like x1, y1, and x2, y2. So I've introduced this. I want you to pause it in just a second and see if you can figure this out and what it means. Find the slope and interpret the context. Go ahead and pause. Okay, hopefully you've come back now after you paused it. But if you haven't paused it, then pause it, then come back. All right. So I'm going to find my slope here. My m, again, y2 minus y1, or 25, minus 10, divided by my x2, 77, minus my x1, which is 50. And here I get 15 divided by 27. Looks like I can simplify that further because they can both be divided by 3. So if I divide the top by 3, I get 5. If I divide the bottom by 3, I get 9. 5 ninths. 5 ninths. And remember, it's y over x. So 5 ninths. Here's how I'm going to think about this. I'm going to say an increase in Fahrenheit, in degrees Fahrenheit, by 9 degrees corresponds to a 5-degree increase in Celsius. An increase of 9 degrees in Fahrenheit corresponds to a 5-degree increase in Celsius. Now, how did I do that? What I did is I took a look at the bottom. Remember, we could have turned 1, on that last page, we could have turned 1 over 1 into, a fraction. 1 is the same as 1 over 1. In this case, this is like 5 degrees, again, because this is our y, so this is our degrees C. This is our degrees F on bottom. Sorry, let me get that in there so we got our definitions there. And so how we relate this, we say a change in the x, a change in that bottom value corresponds to what change in y. So go ahead. Let's talk about the next one. Because in theory, you've already done it. If you haven't, pause it, do the next one too. Okay? The number of cubic feet in water, y, in a reservoir x hours after the water starts flowing into the reservoir is a linear function, linear line, right? The points 40, 3,000, and 64,000 are on the line of the function. So we need to find the slope and then interpret that slope. So let's go ahead and do this. I'm going to treat this as x1, y1, x2, y2, and it doesn't matter. You could have made this x1, y1 and this x2, y2 as long as you don't mix up the 1s and the 2s. This has to both be 1 or both be 2, or both be 1 or both be 2. So let's do our slope here. M equals y2, so 4,000, minus y1, 3,000, divided by x2, 60, minus x1, which is 40. So let's see what I get. I get 1,000 on top, divided by 20 on bottom. You're saying, ooh, how am I going to simplify this? Well, here's a nice trick for you. You can at least divide everything by 10, right? So let's do that. Divide this by 10, I get 100. Divide this by 10, I get 2. Now I've got 100 over 2. I can do that, right? 50. Now, think about it like this. I'm going to do this. I'm going to put 50 over 1. And that's going to help us with our interpretation. Because our y values, this is cubic feet of water. Let's see. Cubic feet of water. And I'm sorry, that was our y's. Cubic feet of water. And our x's was hours. Right? So if we're going to interpret this, 1 hour change, so a change of time of 1 hour, corresponds to an increase in 50 cubic feet of water. So let's write that out. A 1 hour change corresponds to again, a change in x corresponds to what change in y? So a 50 cubic foot change in water, increase in water. Okay, so that's really all we're trying to take care of here. So you find the slope, and then you say the change in x corresponds to what change in y. It's kind of different because when you're doing slope, you're doing y over x. But when you report it out, you can say that this change in x corresponds to this change in y. All right. With that, you can kind of do the rest of them. You can talk about these questions here. I just kind of answered this one. How can you interpret slope in a real world situation? You find your y, you find your x. The change in x corresponds to what change in y? Yeah, that's looking pretty good. I had already before 1 through 6 on this page, 7 through 12 on this page. Now we can start knocking these out. Let's go ahead and do 13 and 14 also. So we're going to do 7 through 14 now. On this page, let's do 15 and 17. You can do 16 if you get real ambitious. 15 and 17. I like number 21. We already had 18 on this page. And, ooh, 22 and 23. 22 and 23. So if you're not sure which ones I assigned, go ahead, just rewind it like 15 seconds so you can take a look at it. Otherwise, that takes care of our slope. We're going to do some practice outside of this one. We're going to do some quizzing, make sure we're all on the same page, and we'll figure out how we're going to test on this thing. Haven't decided yet. We'll get it done. I hope you guys are doing well. Have a great day.